Hey guys, how y'all doing? I have some stuff hooked up, some stuff I want to show you, some updates that we have, and our first discharge test with a 220 amp hour module. So let's go for a ride. Alright, so talking a little bit about where we are on the module itself. I got some existing infrastructure bus bar that I took a hacksaw to, and using another module I actually have that bus bar in front of me. You may recognize this on the negative side. It goes, actually I have this oriented wrong, but it goes all the way down the right side of the module. It attaches to this bus bar that goes around the module and attaches to the very first cell in the series on the positive side, which is negative. So I cut this into the piece that I needed, and since this was just hanging over, I went ahead and wrapped this around, drilled into it. One thing to know regarding this tinned aluminum, it is fragile. So when you start drilling into it, it's going to bind in and twist on itself, and it just becomes a mess. So just do it actually quickly when you drill into it. Don't do it slowly, because it'll just catch. I need to find a way to lock this down a little bit better. I think what I'm going to do is I'm going to use a Dremel to Dremel in something that'll fit into a little slot, Sikaflex in for the glue, and just have something it can rest on. And then that won't move all around during driving. As far as what it looks like under all of this, I can go down a little bit here. That's what it looks like. On the positive side, you can see I did the same thing. Went ahead here to my 40 gauge wire. I went ahead and splurged on the 40 gauge wire because this is the very first cell that's going to make contact with all of my charging equipment and discharging equipment. So I'm really not sure if I'm going to attach a terminal outside of the box and then connect these into, or if I'm going to do inside of the box and just have the cables leading out. And that's going to be up in the air until I more or less decide on that. If you all have any suggestions on this, let me know. You can see this one is nice and secure. It's not going anywhere. And I did some drilling as far as the BMS active equalization right here, and I just attached the same thing here. I heard it's not good to literally have it on top, like active equalization on top of the BMS, because it can mess with that a little bit, so I tried to keep that as separate as I could. Now, the last thing I'll show you, excuse the mess, but the 40 gauge wires are going into a Victron power in, and I'm just using the first portion here. This will be really, really nice later on. This thing can handle 1,000 amps, which is perfect. This was $200, but I think it was well worth it for what I'm about to push through. The last issue that I'm having is dealing with the shunt itself, and this is just loose wire that's plugged into the voltage side. I don't know where to get one of these connectors. If you guys could make some suggestions on where I can get one of those. I did not see it on the company website or what this connector is called. I would appreciate that. And the charger back there is a Hoffman Engineering charger I got off of eBay. It was attached to a couple of Valence batteries that they used, and it charges at a maximum of 20 amps. You see a Ganondale down there, 1200 watt sine wave inverter, around $250. But I really wanted to show you the Lynx power in. That thing is awesome. Hey guys, so updating you with the BMS and how everything's going. As far as for monitoring, I've been very, very happy with Batrium. There's a couple things I learned. in the past 24 hours that I didn't know. For example, the shunt on Batrium is purely for monitoring. It's not for, like for instance, Victron, that has a charging relay on board that you can choose the charge voltage. And I didn't know that when this happened. So once these particular 4 cells get over 3.4 volts, cells 2 and 4 shoot up to 3.67. And that's 3.67 volts after 6 amps of Deli Green charging, trying to move these towards here, as well as 2 amps of bypass. So it's using 8 amps to try to fix these because they're charging too much. And all the Batrium can do is just notify and watch until I start adding different hardware in. Now, currently, this particular discharge has been going on since 8 a.m. and we're down to around 12.8 volts. So I've accumulated around, I'd say, 80 or 90 amp hours. And you can see that these cells are starting to drop at around the halfway mark. And this is one thing I've noticed. So there are issues with cells 2 and 4 that the active balancer is helping negate. I'm curious what would happen if I didn't use the Deli Green balancer to discharge, and I'm going to demonstrate that after we finish with this charge. So I got my BMV712 that I've got set up, and I've got it passing through the battery area over here. There's a couple things I want to show you real quick. Just some of the different numbers I'm going to have in front of me here. The first thing, low cell voltage is going to be 2.5 volts, nominal is 3.2, bypass is 3.3, and then high cell voltage is 3.35. As far as the shunt goes, and this is something that I'm finding very interesting. I really don't understand. Shunt Montu 500 amp. The daily cumulative is showing 300 amp hours, whereas capacity remaining is showing something weird. What I don't understand is if I have only been drawing 8.69 amps over the past 12 hours, how is my amp hours at 300 instead of around 90 to 100? I really don't understand why this number is showing that. And as far as expansion, this is really when you start getting into your different relays. Critical fault can initiate an ABB shunt trip that I do plan on getting and setting up. I'll have to set up a 12 to 24 volt relay for that to happen. I still got to do some research as far as how to make that all work. Now, once you get below 3 volts, as you're starting to see here, these will dip. And the active balancer will kick in with that. But with this active balancer, I'm really looking forward to moving these cells down to where the inverter will fail. And we'll see that here shortly. I did a discharge yesterday, but I forgot to unplug a 4 amp charger. That turned back on about 3/4 of the way through the discharge, so I had to redo that again, and it takes 24 hours to do a discharge at a recommended 8 to 9 amps. Yeah, so overall we're finding solutions to the challenges we're having, especially regarding that Victron BMV. I think that's going to be an okay solution for now, since it is 500 amp. But you got any questions, any suggestions you can make, please do. I've been on DIY battery, DIY power walls, DIY solar power walls. All of those guys on there have been super helpful. Can't thank you guys enough for your help. And yeah, see you on the next one.